All right, in this video, I'll go over a few example problems. All right, so this first one, we have x equal 8a times the quantity b plus 9. In the given equation, place the positive numbers a, b, and c, a, b, and x, which equation correctly expresses a in terms of b and x. So the answer choices are just trying to get a by itself. Okay. You need to know when to use Desmos, when to not use it. This is easy enough where you don't need to use Desmos. Okay. Trying to get the a by itself. The 8 is multiplied by the a. The b plus 9 is multiplied by the a. So we do the opposite. We divide by those. We can divide both sides by 8 times b plus 9. Okay. So we basically get a equal x over 8 times the quantity b plus 9. Okay, that's going to be answer B. How would you do it in Desmos? In Desmos, give a value, let's say 2, and then x will, and actually b, you need number 2, get at 3 or something like that. And then you use x1 instead of x. x1 will equal something, 8 times 2 plus the quantity 3 plus 9. That'll equal x1. And the answer choices, you would put the right side in Desmos, and whatever one of those equaled the a value 2 will be the correct answer. Okay, so a little demonstration. Let's try it out. Okay, but again, you shouldn't waste too much time on an easy problem doing it in Desmos. Okay, so if I had x1 equal 8a times quantity b plus 9, a2, b3, you see x1 equals 192. Okay, and I won't put them all in, but I'll put in b x1 over 8 times the quantity b plus 9. Okay, and the result is 2. All the other ones will give you something different. So I'll just try a x1 over 8 minus the quantity b plus 9, and it came out to be 12. All right, so these are literal equations, just isolating one of the variables. We always do the opposite operations to undo things. Addition, subtraction, opposites. Multiplication, division, opposites. Squaring, square root are opposites. Okay. All right, this one we have our variable in the denominator. Okay. Just by hand, you multiply by a common denominator, which would have been 3 times m minus 1 times m plus 5. And you would end up with a quadratic, and then you would solve, quadratic using quadratic formula or factoring if it can be. Okay. For any kind of equation, you can do that in Desmos. I'd probably prefer you to do in Desmos to eliminate any kind of math errors. Okay. Now notice we use m, but if we wanted to graph it, we need to use x instead. Okay, so it'll be 4 over x minus 1 equal 4 over x plus 5 plus 1 over 3. And we get these vertical lines as we go through the solutions. And I said for m greater than 0, so we really care about the one over here. And we see it goes through 7. Okay. And we can also use the tilde for regression, but you need to use something different than x. I'll just change those to x1s, and x1 equals 7. Okay, that only gives you one of the answers. Okay, you could do a constraint saying that that's the value of x1 minus 7, because 7 was our solution. You do greater than 0, it's either greater than or equal. There we go. So the other answer was -11. Okay. With that one, equations, you put in decimals to make it quicker to solve. Working out the algebra here would take longer than just putting it into decimals. All right, this one, again, you have an equation, so you can use decimals. First, I'll show how to do it by hand. You know, when you get rid of those 7th roots, okay, remember that, you know, x to the 5k minus 1, 7th root is the same as the 1/7 power. Okay. All right, I'm going to get rid of the 1/7 power, so I'm going to take both sides to the 7th power. Okay. Remember, multiply exponents together, 1/7 times 7 is just 1. So you just get x to the 5k minus 1. Okay. X squared to the 7th power be x to the 14th power, 2 times 7. On the bottom, we have 1/7 to the 7th. Those cancel out, give you 1. So that's x to the 11th. Okay. This right side, x to the 14th divided by x to the 11th. We subtract exponents. So we get 5, x to the 5k minus 1 equal x to the 3rd power, 14 minus 11. So once you have x equal like this, x to some power equals x to some power, then make them equal, just set the exponents equal to each other. Okay, solve for k, add 1 to both sides. Divide both sides by 5. Okay, so 4/5, or it comes up to decimal 0.8. Okay. In decimals, they get the 7th root. You just type nth root. Okay, then you put the 7 here. Okay, and then if you do x1, and then I want to do exponent 5k minus 1. Yeah, put that in parentheses. And do a regression. 1 squared over an nth root, 7th root, x1 11th. Okay, I'm going to give x1 a value. You just do 2 is fine. Okay, it's going to solve for k, 0.8, which is the same as 4/5. Okay, so that's how I would do it in decimals. Now, if we were to do this without the x's, you know, without the x1s, just use x and try to graph it. I don't think it works that well. You need to give, I mean, with solve for, you can put a graph because you need to give k a value. We're trying to solve for k. So this won't really, let's see, let's do k to 1. Get these lines. You know, the correct answer was 0.8. Let's see what it will look like. Yeah, it doesn't look like that. So again, the best choice is to plug in value for x and do regression to solve for the k value. All right, this one, 48x minus 72y equals 30y plus 24, and ry equals 1 over 6 minus 16x. The given system of equations, r is a constant. If the system has no solution, what's the value of r? Okay, We see all the x's and y's are to the first power, so these are two lines. Two lines with no solution, just like that. They're parallel, same slope, with different y-intercepts. Okay. So really just need to get the slopes to be equal. Okay, so we're gonna simply put them in y equal mx plus b form. Okay, and then set the slopes equal to each other. Okay, so if I take that first one, try to get the y by itself, subtract 30y from both sides. It's gonna give you negative 102y. Move the 48x to the other side, negative 48x plus 24. Divide by negative 102. Yeah, 48 over 102x plus 24 over 102, or negative 102. With the x's, those two negatives will cancel out, so give you positive. Now in the second equation, divide by r, y will equal 1 over 6r minus 16 over rx. Now we're in slope intercept form, but the x is second, so you gotta pay attention to that. Okay, so those are our slopes, 48 over 102 equal negative 16 over r. And we can cross multiply. 48r equal negative 16 times 102. Okay, so negative 16, 32 divided by 48. Okay, so negative 34. Okay. Now in Desmos, this one's gonna be tricky sometimes, especially if the constant that you're changing is not an integer. Okay, so put it in just like it is. All right, so here it goes to make the red line parallel with the black line. Okay, so notice I need to increase those values. And if I go this way, it doesn't get parallel. If I go this way, it's like it's gonna be better. And I can zoom in a little bit. Now here you gotta be careful. If it was a decimal value, that'd be kind of hard to get like the exact. But here, look, it's gonna be negative 34. You can kind of look out here, this direction to see if they're getting closer or not. To verify. And then this side looks like they're not getting closer, so you're good. Okay. Now this one, these type of problems I actually like to solve by hand, because I'll give you the, if it's a decimal number, this will give it to you clearer. You don't be fiddling around with decimals too much to get the exact value. I've seen some result in like a 0.25, in decimals, or 0.5. And it's a little bit harder to detect in Desmos, so I like doing those by hand, but it's up to you. All right, this next one, x squared minus 34x plus c equals 0. And we're trying to solve for x, what values of x cause that equation to equal 0. Okay, it's a quadratic because our highest exponent is a 2. When we talk about a quadratic and the types of solutions, 2 real solutions, 1 real solution, no real solutions, we use the discriminant. B squared minus 4ac, and that goes back to the ax squared plus bx plus c. Okay. If we want two real solutions, that's going to be greater than 0. We want one real solution that's equal to 0. We want no real solutions that's less than 0. Okay, so no real solution. Okay, technically you get two imaginary solutions. So this goes back to the quadratic formula. Underneath the radical is the b squared minus 4ac. So if that's a negative number, square root of negative number is an imaginary number. Okay. So here we want negative 34 squared minus 4 times 1 times c. Okay, that'd be less than 0. $34 squared is 1156. Okay, so we got 1156 minus 4c less than 0. Subtract 1156 from both sides. Divide both sides by negative 4. Remember with the inequality, when you divide or multiply by negative at the end, you gotta change the direction of the inequality. Okay. You can get c greater than 289. Okay, this matches up with the c greater than n. So what's the least possible value for n? 289. Okay. All right, this one, y equals 2x plus 5, y equals kx plus 3. In a given system of equations, k is a constant. The system has exactly one solution, which the following can be the value of k. All right, so two lines, one solution that occurs when they have different slopes. Okay, so this person has a slope of 2, so we don't want the second one to have a slope of 2. It needs to be different, so only option 2 there for a 5, so B is the correct answer. Okay. All right, this next one deals with inequality. So you could use Desmos to graph all those. That's fine. Again, if you do it fast, do it by hand. We care about the intercepts at 9, 0, and 0, negative 6. Okay. Now here, all the answer choices have a slope of 2/3, so we don't really need to figure out the slope. We know the y-intercept is at negative 6. Only one answer choice has negative 6 as a y-intercept, so we do A. So this one's faster than putting them all on Desmos to see which one looks right. Okay, so if you can spot it right away, do it that way so it's faster. All right, this one, P of t equals 24.8 times 1.036 to the t power. The function P gives the predicted population in millions of a certain country for the period from 1984 to 2018, where t is the number of years after 1984. According to the model, what's the best interpretation of the statement P of 8 is approximately equal to 32.91. Okay, so this is function notation. P of t is, P is the name of the function. It's a variable. It's a it's a function that correlates with the t value, function of t. And that's our independent variable, just like the x would normally be. The output of the function is, the p of t value, or the y. Remember, we replace that with y. Okay. So here, important to look at the units. So P of 8, and in the parentheses is the t value. Okay, so t equals 8. Okay, and the result of that, P of 8 is equal to 32.91. What's the units of t? T is the number of years after 1984. So this is 8 years after 1984. And what's the output of the function? The p predicts the population in millions. So 32.91 is population. In millions. Right, so what answer choice matches up with that? A says in 1984, the predicted population of this country was approximately 8 million. Okay, 1984 was the initial year, so that would have been actually P of 0. Okay, and that's not what we have. We have P of 8. B says in 1984, the predicted population of the country was approximately 32.91 million. Again, 1984 correlates to a t value of 0. Okay, look at D, 32.91 years after 1984. That would have been P of 32.91, where T was 32.91, so that's not right. C says 8 years after 1984, so P of 8. Okay, was approximately 32.9 million, so that's the correct one. T of 8, and then the output of the function 32.9, which represents, in millions. So C is the correct one there. All right, this one, the company has a newsletter. In January 2018, there were 1,300 customers subscribed to the newsletter. For the next 24 months after January 2018, the total number of customers subscribed to the newsletter each month was 7% greater than the total number subscribed the previous month. Which equation gives the total number of customers C subscribed to the company's newsletter M months after January 2018, where M is less than or equal to 24? Okay, so we're increasing by 7% each month. What is that? That is an exponential growth equation there. Okay, so that's A equal A naught, that's quantity 1 plus R to the T power. Okay, where A naught is the initial amount, and year 0, or when T is equal 0. R is your growth percentage, change it to decimal. Okay, so our initial was 1,300, formed by 7%, so 1 plus 0.7, the T, in this case, M, for months. Okay, so 1,300 times 1.07 to the M will be the correct one. Okay, so that looks like B. Okay, so remember the number in here is, either 1 plus the growth rate or decay rate, or 1 minus. So it's not this, because this would be 1 minus 0.93. Okay, C would have been 1 plus 0.7. This would have been 1 plus 6. Okay, so exponential growth 1, it grows by 7% each month. So you could have said, after 1 month, we're going to add 7% to that. That would give us 1391. So after 1 month, it'll be 1391. So you could plug in M M to the answer choices and see which one gave you 1391. That's another way to do it. Okay. All right, this one here, P of X plus 57 equals X squared. Given equation relates the value of X and X corresponding value of P of X for the function P. What is the minimum value of function P? Okay, normally for function, we have the function notation by itself, so I'm going to rearrange that. They do that to kind of trick you a little bit, so just put it back to how it normally would be. P of X equals X squared minus 57. And what type of function is this? X squared, that's going to be a quadratic or parabola. Okay, parabola has a min or max at the vertex. Okay, the coefficient of the x squared is +1. So when it's positive, it opens upward. So the minimum will be at the vertex. Okay. You can graph this in Desmos and see what that vertex is. If you're familiar with vertex form, we got y equal a times x minus h quantity squared plus k. Okay, where hk is the vertex. So we just have x squared. That means it was x minus 0 squared. Okay, and then minus 57. So vertex is at 0, comma, -57. And the y value is the min or max of the function, so -57. Okay. All right, so hopefully you learned something from these questions. You gotta know a little details of all these, all the definitions, what's a function, all the different, exponential growth, linear equations, quadratics. You need to memorize and be familiar with these types of functions, and those have to come to your mind pretty quickly because you got like a minute and a half to solve these problems. All right, thanks.